Welcome to Accelerated Solidworks 2025 Learning. I'm Kelvin Wee. This course provides a quick and clear introduction to common features of Solidworks, sketch, part, assembly, drawing, and it is a free set of courses. Now let's start our learning. Lesson 6, Feature Learning 2. In the previous lesson, we learned the function of the extruded boss base and the design tree. In this lesson, we will learn about extruded cut, reference geometry, curve, revolve, boss base, and sweep function. Let's start by opening the part feature model you drew in the previous lesson. And if you didn't save it or delete it in the previous lesson, then you will definitely understand the importance of saving the file. If you really don't have a saved file, just draw a model of the same. In this lesson, we are also going to learn about this part. So if you still want to save this file, save it as a separate file and start learning again. We can click Save As in the file to enter the name and save as Feature Learning 2. Click Save to see that the file name becomes the Feature Learning 2. We click Open in the file to view the file feature modeling. The learning file is still there. And now click Close. Let's start this lesson officially. Now for the extruded cut function, as the name suggests, it is the function of cutting solid with sketches. Let's draw a circle in this surface first. Click on that sketch. Select this face. Start drawing a circle with mouse gesture. First draw a circle on the left. Now switch directly to the Feature tab and click on the extruded cut. You can see the preview in the part window. We can see in the property box that this is a hole with a depth of 10. Or we can click on the blind to activate the drop-down menu. Can select Through All. And we can see that this hole is penetrated, which is the end condition of the extruded cut. And the start condition of the extruded cut, the direction 2 option, is actually the same as the extruded boss base method. And you can draw inferences from one to the other. I won't go into these features here. Now click OK to confirm the true hole and you are done. Let's click on the feature again. Click on Edit. We notice that one of the conditions of the end of the cut is up to surface. Select it. We click on the inner surface in this shape and observe that the cut stops when it reaches this face. So can we choose a datum plane? For example, the farm datum plane in the middle of this model? The answer is yes. How to choose this datum plane? Now our design tree is obstructed by attributes, but we notice that the upper right corner of the property box is further to the right. Click on the triangle icon here. Click on it and you can see the design tree appear. Now hover over the front plane in the design tree and the front plane will temporarily appear in the part window. Once you have determined that this is the face we need, click on it to see that the cut ends in the middle of the model. In addition to the fact that the part has 3 planes by default, we can also create the plane ourselves. Click on the reference geometry in the feature. Click on the plane in it, and there are three references to the plane. Don't look at these three bells and whistles and think this is difficult. This is actually very simple. I will start with the simplest. Let's set up a datum that is 5 mm offset from the front plane. We find the front plane in the design tree and click it. We can see in the part window that there is a parallel face in front of the front plane. In property box, we can see that this is an offset distance of 10 mm plane. We change 10 to 5. Click OK to this face to establish it. Notice that this face is visible in the part window, but by default the three datum planes are invisible. Why is that? Seeing the datum just established in the design tree, the icon on the left is blue, and the icons for the default three datum planes are transparent. We can click on the icon of an eye in the pop-up menu of the front datum and click on the eye to see the front datum is displayed. Now let's create another circle and cut it to the new plane as the end. Click on the sketch to draw or select the face. Use a mouse gesture to activate the circle. And when the drawing is done, click the extrude cut button in the feature. Click on the blind to activate the drop-down menu and click on up to surface. Select the datum in the part window. Click OK to end the drawing. And now observe the part. Do you think these two datums affects our observation of this figure? We can click on the datum in the design tree and find the hide button in the pop-up menu. That is the eye icon with a slash button. Click on it to hide, and the same operation can be displayed again. So is there a way to hide all the datums with one click? And it is okay to show the plane when we need it. We find this eye icon in the view tools above the part, and we are prompted to hide all types. We click on it so that the datum is all hidden, and when we click it again, it will appear again. And we click on the triangle button next to it, and we can see that there are quite a lot of display types. In fact, a lot of time we turn on the display plane, and after turning off the display of the plane, we can also click on the plane in the design tree to display and select it. Here is how to sweep both base, which is how you take a sketch along another sketch to generate solid for a path. Next, click on the colored datum in the design tree. Click on the first icon in the pop-up window, which is the sketch icon, and we will start to draw a sketch on the front datum. Through the study of these two lessons, we found that there are actually many ways to implement the same functions of Solidworks. So when learning, you can think more about whether it can be like this or whether it can be like that. And then try more, and you will definitely find some new drawing methods. Now we draw another circle next to it. Use the mouse gesture to activate the circle. After the drawing is done, use the mouse gesture to activate the line. Create a straight line between the center of the circle and the dot. Press ESC to exit the line drawing. Click the line Click on the horizontal line in the property box, and then click on the bottom as the construction line. Click on the Submit button. The circle is now observed in the design tree by clicking on the front plane. And although it is drawn on the top plane, its center passes through the top plane. Now let's sketch the front datum and see if it can be combined with the center of the circle. Click on the front datum, click on the sketch in the sketch tab, and activate the line with a mouse gesture. Use the mouse to find the center of the circle. The system will appear the coincident icon. Click on it and then draw a connected line upward. After the drawing, we have a question, that is, the previous sketch is just perpendicular to this perspective. It is not easy to observe the intersection of this polyline and the center of the line. How to better observe? Hold down the middle mouse button and move the mouse to see that the polyline does indeed coincide with the center of the circle. Click OK to submit the sketch. And now click the Streak button in the feature bar, and the first column can be seen. The button is to select the cross-section sketch of the street. Click the circle in the part window. The second column is the street reference line. Select the polyline just drawn. You can see the street preview graphic appear. Click OK to submit this operation. Let's introduce the curve coupled with strip. To make a spring model, we draw a circle on the top datum plane. Click on the top datum plane. Click on the sketch in the menu. Use the mouse gesture to activate the circle. Draw a circle, and then use the mouse gesture to activate the smart dimension. Setting 20 mm. Click OK to submit the sketch. Then click on the feature bar. Find the curve button in the feature bar, and click to find the helix and spiral in the pop-up menu. Click on the circle just drawn. Now hold down the middle mouse button and drag the mouse to zoom in to observe the spiral preview. There is a pitch and revolution in the property setting on the left. The pitch we set to 5, the revolution we set to 10. Then click to confirm that the pitch is now 5, the revolution is 10, and the spiral with a diameter of 20 is designed. And the button of this spiral is not in the sketch tab. So the next time you want to find the spiral button, remember it is in the feature tab. Now click the Streak button in the feature tab. Select the circular profile in the first column of the property box. Then select the spiral you just designed. And then look down to the diameter of the circular profile, which is the diameter of the spring. Enter 3. Click OK to submit. And this time, the spring model will be generated. These are the two methods of strip. One is sketch profile strip, and the other is circular profile strip. The following is an introduction to the revolve box base, which is a particular important feature in Solidworks. Let's draw a water cup and imagine if the easiest way is to spin it out. Now click on the front, click on the sketch, and in the part window, move to the screen to the right and draw a half section of the glass on the left. Use a mouse gesture to activate the line to start drawing. Let's draw the cup in the picture. Draw its rotation section with the line. After drawing, select the line in the rotation center and set it as the construction line in the property box. Now, according to this diagram, roughly add the size. First, add its thickness. The wall thickness is set to 3 mm. The base thickness is set to 10 mm. Now set its diameter to 90 mm. You can see that the size passes through the center of the construction line, become the dimension diameter. Then the height is marked 93 mm, and then the angle is set. We set to 85 degrees. If you find that the sketch is too close to the graphic on the right, you can box select the line, then click the Move Entity button in the Sketch tab, and then click the first point in the diagram as the starting point of its movement. Now move the mouse and the sketch will follow the mouse. And we will move a little to the left to make sure that we don't touch the shape we drew earlier when we rotate it. The sketch has now been moved a distance to the left, but the angle is a little less pleasing to the eye. The number 85 moved to the right. We can click on 85 and then move the number 85 to the appropriate place. Now this sketch is still blue. We click on one of its endpoints, click Fix in the property box or the pop-up menu bar. You can see that the whole sketch turned black. The sketch has been fully constrained. Now click on the Revolve Boss Base in the Feature tab. You can see the yellow preview shape. The outline of the cup will appear. The Revolve Boss Base command will automatically identify the construction line in the sketch as the rotation center. When you see the first column in the property box, you will find the axis of rotation that is automatically selected. The second column is the angle of rotation. Usually we rotate 360 degrees. Now click to determine the shape of a cup and it appears. We can also generate a screw by Revolve Boss Base. Proceed to select the front plane to sketch. Click on the front plane in the design tree. Click on Sketch in the pop-up menu, and we will draw a M10 screw in the blank space. Again, use the mouse gesture to activate the line, drawing the center line first, and then the other outline. This time, we don't set the center line as a construction line. Let's see what happens. Now mark the size. Mark the thread diameter 10. And you can see that now the center line is not the construction line. We can't mark the diameter, only the radius. Then the radius is 5. Then label the length 16. Note the height of the screw head is 10 and the radius of the screw head is 8. Now when you click on the Revolve Boss Base button in the Feature tab, you can see that the system does not automatically select the axis of rotation. This is because there is no construction line in our sketch, and the system cannot recognize the axis of rotation. But we can manually select the axis of rotation. Click on the line of the axis of rotation in the sketch to see that there is also a preview of the screw now. Click the Submit button to confirm this edit. While the screw is threaded, how to add a thread? Now click on the Insert Annotation, Cosmetic Thread, and then click on the thread starting line of the screw in the part drawing. And you can see that a thread-like map appears in the drawing. This is because the real thread geometry is too complex to display than it a decorative thread. Because we select an edge with a diameter of 10 and the system automatically assign the thread size to M10. Of course, we can also customize the center of this thread in these three columns. And then the depth of the thread. Our thread was originally formed in the next side, so there is no need to modify it here. Now click OK to determine the thread to draw. This lesson is completed here, and in the next lesson, we will talk about the last lesson of the feature 2.